Hi, seventh graders. Today we're going to continue our work with two-step equations. This time, each of the problems that we do will focus on writing equations for situations that involve discounts. So you're going to see how our previous understanding of discounts and percents from earlier this year will help us as we continue writing equations for different types of real-world situations.
Before we start any of the equations, though, let's do a quick reminder. If something is 40% off, what percent do we still have to pay? Well, we know it's always going to total 100%, so to find the percent we still have to pay, it's going to be 60% of the original price. If we get a 10% discount, what percent of the original price are we still paying? That's right, we're paying a 90% of the original price. One more thing to do a quick refresher on is turning a percent into a decimal. So if we have 80%, how would we write that as a decimal? If you said 0.8, you would be correct. Remember, we take our decimal point and slide it twice to the left to turn it into a decimal. If we had 72%, how would we write that as a decimal? If you said 0.72, that would be correct. And finally, if we had 5% and we wanted to write that as a decimal, what would we do? We would do 0.05. Again, sliding that decimal twice to the left and putting a 0 in as a place marker. All right, that's enough of the review stuff. Let's get to our new material. So, Lucas bought a tablet that was on sale at a 15% discount. He also bought a case for $24.99. Lucas spent a total of $237.49. Write an equation to find the original cost of the tablet. All right, so when I look at this, I'm trying to figure out here, well, what are we going to use for our variable? What's our unknown? What are we trying to figure out? Well, we're trying to figure out the original cost of the tablet. So let's call that our C, or maybe we could call it X, give it a variable, okay? So C is going to be the original cost of our tablet. So part A says write an expression to represent the cost of the tablet. So not the original cost, but the tablet after it's on sale for a 15% discount. All right, well, here's a tricky part, guys. If we know that it's a 15% discount, what percent of the original cost of the tablet do we still have to pay for? Well, I know that 100 minus 15 is 85, and so that means that Lucas here still has to pay 85% of that original cost when he's getting a 15% discount. So now we can actually write our answer here for part A. An expression to represent the cost of the tablet is going to be 0.85 times our variable, times C. Okay, 85% of the original cost. All right, then letter B, write a term to represent the cost of the case. Well, the case, we already know the cost of. It's $24.99, so that's just nice and straightforward there. And then part C, add them together and set the sum equal to the total amount spent. In other words, write our equation. So we're going to take the expression that we wrote to represent the cost of the tablet, and we're going to add to that the term that represents the cost of the case, and we're going to set it equal to the total amount that Lucas spent. Here's what that equation looks like. 0.85C, so 85% of the original cost, plus the $24.99 that he spent on the case is equal to the total amount of money he spent, $237.49. All right, so there's our equation, our algebraic equation that represents this situation. Now go ahead and solve this equation to see what you get for C. All right, when I solved my equation, I first took off $24.99 from both sides. I got 0.85C equals 212.50. Divided both sides by 0.85, and I find out that C equals $250. In other words, the original cost of the tablet is $250. All right, this particular problem is going to have us working with a discount on your entire purchase. So this says Emily buys a hat and gloves with a coupon for 30% off her entire purchase. The gloves cost $35 before the discount. Her bill is $44.80. Write an equation to find the original cost of the hat. All right, so let's break down what we know here in this problem. We know that Emily's getting a hat and she's getting gloves, and we have to add those two together, and then we're going to take 30% off of that entire purchase. And when we do that, her total bill is going to be $44.80. All right, I'm just going to kind of put something here. I'm going to say, okay, hat plus gloves. This isn't something you need to write. I just want to kind of show you where this comes from. And then times, if it's 30% off, we know she's still paying for 70% of the original, so that's 0.7. 0.7 times the hat plus the gloves is going to give her $44.80. All right, now we got to kind of look at what we know here. Well, we know the cost of the gloves before the discount is $35. So instead of that, I'm going to end up putting my 35 in. And then the cost of the hat now is the only thing we don't actually know. So that's going to be where I put my variable. So I'm going to rewrite my equation now to include all that information. So we take the cost of our hat plus the original cost of our gloves, which was $35. And then to get a 30% discount, that means we're still paying for 70% of the original cost, and her total bill is $44.80. All right, now we can go in and solve this equation to find the cost of the original, or the original cost of the hat. All right, so one way we can do this would be to distribute 0.7 times H plus 0.7 times 35, which is $24.50. And all of that is still set equal to $44.80. All right, then we're going to go ahead and we're going to subtract $24.50 from both sides. So we're taking off the cost of this here, and we find out that we have 0.7 times H equals, I'm doing my math here, let's see, $20.30. And then finally we need to go in and divide both sides by 0.7 to find out what H is. And I get H equals, let's see, 0.7, $29. Well, that's kind of sloppy there. So the original cost of the hat was $29. Let's just kind of check and make sure this answer works here with this problem. So if she buys a hat and gloves, and we know the gloves originally cost $35. Now we're thinking the hat costs $29. Well, if we add 29 plus 35, this would have been $64 before the discount. And then if we take 30% off of that, that would be, here, 30% of 64 is $19.20. That's the discount she gets. So then you do 64 minus 19.20, and we get an answer of $45.80. And that is what we said the bill was up top. So we just proven here that our answer of $29 is correct. All right, this particular problem will be on your homework, so you can go ahead and complete it on your homework page as we do it together here. It says, Tyrone went to a basketball game and bought a jersey that was on sale at a 30% discount. He also bought a hat that cost $37.89. Tyrone spent a total of $83.39. We're asked to write an equation to find the original cost of the jersey. All right, I'm going to use X for the cost of the jersey, or the original cost of jersey. Original cost jersey. All right, so we've defined our variable. And now let's kind of look again to see what do we know here that we can write an expression for. So he bought a jersey that was on sale at a 30% discount. So if he's getting it for 30%, what percent did he get off? Or what percent is he paying? That would be 70%, so 0.7 times the original cost of the jersey, plus he got his hat for $37.89. So I'm going to do plus $37.89. And again, we know the total here is $83.39. And now solving this is just a matter of doing inverse operations to get our x by itself, and I'm going to have you pause the video, solve this on your page, and then push play to check and see how you did. All right, so when I solve my equation by subtracting 3789 and then dividing by 0.7, I find out that x equals $65. So the cost of the original cost of the jersey is $65. Our final example that we'll do together also comes from your homework, and this is one with a discount on the entire purchase. Edward buys sunglasses and a wallet with a coupon for 15% off his entire purchase. The sunglasses cost $12 before the discount, and his total bill after the discount was $28.90. Write an equation to find the original price of the wallet. All right, so Edward's buying sunglasses and a wallet, and then he's getting 15% off both of those together. So the thing that we don't know, our unknown here, is the original price of the wallet. So let's use W for our variable here for the cost of the wallet. All right, so with that, we're going to say whatever the cost of the wallet was plus the cost of the sunglasses, which we know now is $12. Now, when we add those together, that would have been his original bill, but he's getting 15% off that sum. So 15% off of W plus 12 means he's still paying for 85% of that amount. So we're doing 0.85 times the cost of the wallet plus the sunglasses. And we know that when we add that up, we get $28.90 for his after the discount total. All right, so I'm going to have you pause the video, solve this. You can do one of two things. You can either distribute 0.85 times W plus 0.85 times 12, or if you recall, another way to solve this would be to divide both sides by 0.85 right off the bat, and then go from there. So pick your method, try it on your own, and then push play when you're ready to see how you did. So what I did first was I divided both sides by 0.85 this time, and now I'm left with W plus 12 equals 34. When I subtract 12 from both sides, I will be left with my W, which is 22. So the original price of the wallet was $22. I also included another way to solve this over here. If you use the distributive property first, you can pause and check your work with that. All right, so that's it. Now it's your turn to practice. As always, let me know how I can help. And take your time, reread, and use our examples for guidance. Thanks for watching.